is lesson 3.5, writing ratios and proportions. You should be on page 162. You've used rates throughout this book up to this point. Here would be a sample rate like 50 miles per hour. A rate is a special type of ratio. So what's a ratio? We need to talk about that. A ratio uses division to compare two quantities. So in other words, a ratio is a division of two different amounts, quantities of something, okay? You can write a ratio in three different ways, and they're shown here. You can write it verbally, like something to something using the word to, or you can write it as something to something using a colon, or you can write it in fractional form like a division. All three of these would be a way to write a ratio. I would get that in your notes. Make sure you're aware of those three ways. Each of these would be read the ratio of A to B. Here would be some examples of writing a ratio. Derek and his brother decide to combine their CD collections. Derek has 44 CDs and his brother has 52 CDs. Find the ratio specified. So here's the first ratio. The number of Derek's CDs to the number of his brother's CDs. So let me write that out. I'm comparing Derek's CDs to his brother's CDs. That would be comparing 44 to 44, I meant to say, to 52. And if you put 44 over 52 in your calculator and you simplify the fraction, that should give you 11/13. So you might want to practice that process again. Type in 44 divided by 52. Then hit the math key on the far left of your calculator. And the first option there is frac. Press enter a couple times, and you'll get 11/13. You can reduce that on your calculator. The second ratio they want me to write, the number of Derek's CDs to the number of CDs in the entire collection. Well, I'll do that. I'll write it out. Derek's CDs compared to the total CDs. Well, Derek's CDs are 44. The total is the combination of 44 and 52, which is 96. So I'm doing 44 over 96. Again, you could put that in your calculator. 44 divided by 96, hit the math key, fraction, enter. You should be getting 11/24. So the ratio for this second situation would be 11/24. So writing a ratio is pretty simple. You're just writing your numbers. It's a comparison of numbers in a fraction, basically. Let's talk about a proportion. A proportion is an equation that states that two ratios are equivalent. Again, I'd get that in your notes. The word equivalent means equal. So you can see this picture here. A proportion is two fractions. Really, ratios are fractions. We have two fractions that are equal. You can see it right there. Ratio is fraction. I have two equal fractions. Now, if one of the numbers in this proportion is unknown, so in other words, if one of the numbers is a variable, you could solve the proportion to find the unknown number. To solve the proportion, you can use the same methods you use to solve equations, which would be onion. We could use the onion method, isolate the variable. Here would be an example of using the onion method on number 3. W over 35 equals 4 over 7. So you notice W is the center of my onion. The next layer is the divide by 35. Well, how do I get rid of divide by 35? Well, I hope you're sitting there thinking, well, you times by 35 on each side. So you notice I did that. When I multiply the left side by 35, it's going to cancel out the divide by 35, which leaves W by itself. And then over here, I got to do 4/7 times 35, and that ought to be giving you 20. And you ought to be able to take 20 and check it. You should check. Is 20 divided by 35 going to give me the same thing as 4 divided by 7? And yes, it does. Okay, so I'm sure some of you are thinking, wait a minute, I've learned that I can cross multiply to solve that. You can, We're going to learn more about that and look at that more closely in the next lesson. Okay, so there's really a couple ways you can solve a proportion. You can use the onion method, or you could cross multiply and solve. One of the great things about proportions is they make story problems very easy to solve. There are different ways you can set up a proportion. Consider the following problem. A recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints? Now, the way I always teach this is you guys are great at music, you like music, you listen to music. When you set up a proportion, there has to be a rhythm to it. So here's what I mean by rhythm. I'm going to write out how I would solve this. Let me read it again. A recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints? So here's my little rhythm. I'm not great at music, but think about this. 30 tomatoes compared to 12 pints of salsa has to equal how many tomatoes compared to 4 pints of salsa? Okay? You see how I have tomatoes compared to salsa equals tomatoes compared to salsa. It's almost got a little beat to it. Tomatoes to salsa equals tomatoes to salsa. All right? If you set it up that way, you're going to have it set up right. Now all I have to do is solve. Well, let me get rid of my labels here. I have 30 over 12 equals x over 4. So if I think onion, I have to get rid of divide by 4. I'll times by 4 to make that happen. And the divide by 4 times 4 cancels. I'm going to write my x down here underneath this. And over here, I can take my calculator now. 30 divided by 12, and I'm multiplying that by 4. If I'm doing this right, I ought to be getting 10. And then I can check it. 30 divided by 12 should be giving me the same answer as 10 over 4, and it does. Okay? We're going to try that do one more example of that. So again, I hope my rhythm example makes sense. Tomato to salsa equals tomato to salsa. There's kind of like a little rhythm to that. Can you hear it? Okay. Let's do this astronomy problem. It's another one of these. They want me to set up and solve it. It's a word problem. When 2 full moons appear in the same month, the second full moon is called a blue moon. So on average, 2 blue moons occur every 5 years. Find the number of blue moons that are likely to occur in the next 25 years. So let me get my rhythm out. Obviously, you can tell why I'm not a rap star with my rhythm, right? But anyway, let's get my rhythm out. 2 blue moons compared to 5 years would have to equal how many blue moons? My pen's not responding. How many blue moons compared to 25 years? Okay? So I'm trying to write that in here with my mouse. All right, so ready? Can you hear my rhythm? Blue moons compared to years equals blue moons compared to years. As long as I have it set up with that rhythm, I'm going to have it set up right. Now I just have to solve it. So, okay, let me write this down. I have 2 over 5 equals x over 25. And since I'm dividing by 25, I should multiply by 25 to solve. And divide by 25 times 25. I get x, and over here, 2/5 times 25. If I'm doing my mental math right, I ought to have 10, and you can even use your calculator when you do these, of course. Let me check. 2 over 5, when I put that in my calculator, should give me the same answer as 10 over 25, and it does. So the answer must be, there must be 10 blue moons in 25 years. So again, if you just set it up with the rhythm, blue moons compared to years equals blue moons compared to years. Now it's just a matter of doing the arithmetic with it, okay? I'm going to stop my video here. If you have questions, make sure you ask in class.